Most points follow a clear pattern. But one point doesn't. Should it change the entire trend? That unusual point has a name. It's called an outlier. And outliers can change how we interpret data. Look at this scatter plot again. Most of the data points follow a clear pattern. But that single outlier pulls the average away from where most points actually are. This is the key idea you must understand for the SAT. The mean depends on the values themselves. When one value is extremely large or small, the mean moves with it. The median, on the other hand, depends only on position. It cares about order, not magnitude. That's why the median stays almost in the same place, even when the outlier is added. Now here's the SAT level question. If the problem asks, which measure better represents the typical value? You must stop and ask yourself, is there an outlier? Is the data skewed? Is one point dominating the calculation? If yes, the mean may be misleading. On the SAT, this is not a calculation problem. It's a judgment problem. You're not being tested on formulas. You're being tested on whether you know when a formula should, or should not, be trusted. That's why SAT questions often ask, which is more appropriate, the mean or the median? Not because it's tricky, but because real data is messy. And your job is to decide which summary actually tells the truth. So far, we've talked about averages. But when we look at scatterplots, the real question is not just where the center is. It's how close the data points are to a line. Take a look at this graph. Each point is near the line, but not exactly on it. That vertical distance between a point and the line matters. Some points are very close. Others are farther away. That distance tells us something important. It tells us how well the line represents the data. If most points are close to the line, the relationship is strong. If many points are far away, the relationship is weak, even if the line looks reasonable. Notice something else. That distance is always measured vertically. Not sideways, not diagonally, straight up or straight down to the line. On the SAT, this idea appears again and again. You may not see the word residual, but you'll be asked to compare how well different lines fit data. And the key question is always the same. Which line keeps the points closer overall? That's the intuition you need, before we talk about formulas. Now we face the real question. If there are many possible lines, how do we decide which one fits the data best? Look at these two lines. At first glance, both seem reasonable. Neither looks obviously wrong, but we don't judge a line by one point. We judge it by all the points. For each point, there is a vertical distance to the line. Some distances are small, some are larger. What matters is how these distances add up overall. Now here's the key idea. If we simply add distances, positive and negative values could cancel out. That would hide how bad a fit really is. So instead, we make every distance positive. We square them. Squaring does two things. First, it prevents cancellation. Second, it penalizes large errors much more than small ones. A line with one big miss is worse than a line with many small misses. The line that minimizes the total of these squared distances is called the least squares line. On the SAT, you don't need the formula. You need the reasoning. The best line is the one that keeps the points as close as possible overall. That's the idea behind least squares. Take a moment and really look at this graph. You see the same data points and two different lines. At first glance, both lines seem reasonable. Neither one looks obviously wrong. This is exactly the kind of situation the SAT likes to test. Now, don't rush to an answer. Don't focus on just one point where a line looks especially good or bad. That's the trap. Instead, remember the rule. Consider all data points, not just one. Ask yourself this question: which line keeps the points closer overall? Some points are slightly above the line. Some are slightly below. What matters is the total pattern, not a single perfect match. One line might miss badly at one point. Another line might miss a little. At many points. So you have to step back and judge the balance. Which line represents the data better as a whole? This is not about calculation. It's about reasoning. If you think this way, you're thinking exactly like the SAT wants you to. Take one more look, make your choice, and then let's check the answer. Here's the key idea. The correct answer is not the line that looks perfect at one point. It's the line that keeps the data points closer overall. When you compare the two lines, one of them has a better balance. It may not be the closest everywhere, but across all points, the total distance is smaller. That's what the SAT is testing. You're not being asked to calculate. You're being asked to judge. If you focus on the overall pattern instead of a single point, you'll choose the correct line. This is exactly what line of best fit means on the SAT. Let's try a quick practice problem. You see the same kind of scatterplot, with two different lines. Your task is simple: which line fits the data better? Don't focus on one point. Look at the pattern as a whole. Ask yourself this question: across all points, which line keeps the distances smaller? Pause the video for a moment and make your choice. Now, let's think it through. One of these lines clearly runs through the center of the data. The other stays consistently above or below the points. That tells you everything you need to know. The correct answer is line B. Line B is the better fit because it keeps the points closer overall. When you look at this scatterplot, don't focus on just one point. Instead, look at all of them together. Notice how line B runs through the middle of the data. Some points are above the line, and some are below it, but the distances stay relatively small. That balance matters. Now compare that to line A. Line A may look similar at first, but across the graph, it stays farther away from many points. Those distances add up. On the SAT, this is exactly how better fit is defined. You are not asked to calculate anything. You are asked to judge the overall pattern. The line that stays closest to the data as a whole is the line of best fit. And in this case, that line is line B. Now this one is a bit harder. At first glance, one of these lines might look better in certain areas. For example, around the middle of the graph, line A seems to pass very close to several points. But here's the key idea. Don't focus on just one part of the graph. When deciding which line fits the data better, you have to consider all the points together, from the leftmost to the rightmost. Ask yourself this: which line keeps the overall distances between the points and the line smaller? Even if a line looks good in one region, a larger miss elsewhere can matter more. Take a moment to scan the entire graph carefully, and decide which line provides the better overall fit. Let's walk through this carefully. At first glance, line A might look like a good fit. In the middle of the graph, several points sit very close to line A, and that can be misleading. But remember the key idea we learned earlier: we don't judge a line by one area or a few points. We consider all the data points together, across the entire graph. Now scan from left to right. Ask yourself where each line starts to drift away. With line A, the gaps become a bit larger near the upper right part of the graph. Even one larger miss can affect the overall fit. Line B, on the other hand, may not be perfect at every point, but its distances stay more balanced overall. It avoids big mistakes, and the line stays close to the pattern as a whole. This is exactly what the line of best fit is trying to do. It minimizes overall error, not just error in one region. So even if line A looks better in one spot, line B keeps the points closer as a whole. That's why line B is the better fit. On the SAT, this kind of question is not about formulas. It's about reasoning. Which line stays closest to all the points overall? Take your time with this one. 2 lines are shown, and most of the points follow a clear linear pattern. But there is one point that stands noticeably apart. One line moves closer to that distant point. The other stays closer to the main cluster of data. Which line fits the data better? Don't focus on just one point. Don't focus on just one area. Look at all the points together, and think about which line best represents the overall pattern. Let's break this down carefully. At first glance, line A can feel very convincing. It moves closer to that distant point, and it looks like it's being more honest by trying to include everything. And that reaction makes sense. Ignoring a point can feel wrong. But the key question is not whether a line respects one specific point. The real question is how well the line represents all the data together. Now think about what happens with line A by moving closer to that one distant point. The line is slightly pulled away from many other points. Each of those small misses adds up. Line B makes a different choice. It does not chase that one point. Instead, it stays close to the main pattern formed by the majority of the data. This is the crucial idea. In data analysis, one large error can matter more than many small ones, but a line that consistently stays close to most points usually represents the data better overall. Line B keeps the overall distances smaller across the entire graph. It sacrifices being close to one point in order to stay balanced everywhere else. That's why line B is the better fit. On the SAT, you're not expected to calculate anything here. You're expected to reason. When you see a situation like this, ask yourself, which line best represents the overall pattern of the data? Not the most dramatic point. Not one specific area, but the data as a whole. That reasoning is what leads you to the correct answer. Let's wrap up what really matters for SAT data analysis. Throughout this video, we didn't focus on formulas or calculations. Instead, we focused on how to think. When you see data, your first job is to understand the pattern. Not just one point, not just one section, but the overall relationship. Outliers matter, but they don't always decide the answer. Sometimes the best model includes them. Sometimes the best model represents the majority more faithfully. The key skill is judgment. Ask yourself, which model explains the data as a whole? Which one stays closest overall? Which one best captures the real trend? That way of thinking is exactly what the SAT is testing. If you can look at a graph and reason this way, you're not just solving test questions. You're thinking like a data analyst. And that skill goes far beyond the SAT.